All right, well, we've been asked to work out the current through the 100 ohm resistor, and that's just here. So how are we going to do this? Well, we've got these other resistors here, but we don't have any current information. So what we can do is actually use Kirchhoffs' second law, and that says that for any closed loop in a circuit, the sum of the EMFs is equal to the sum of the potential differences. Now, if you prefer, it's often easier to think of this as the sum of voltages supplied must be equal to the sum of the voltages that we actually get out. Okay, so let's have a look at the circuit again. So we can see that the 100 ohm resistor is part of this loop in the circuit, and it's also part of this loop in the circuit. So in principle, we could use either loop. However, I'm going to use the right-hand loop. Okay, so the cell is trying to push current this way, and then this 3-volt cell is pushing current this way. So we should have a current going down here, and that's what we need to work out. So let's use Kirchhoffs' second law. So we want the sum of the EMFs, the sum of the voltages supplied. So we've got 9 plus 3. Okay, so that's the left-hand side of our equation. 9 plus 3. And then the sum of the voltages we get out, well, we use V equals IR for that. So we know that the voltage we get through this 100 ohm resistor is going to equal the current times the resistance. So V equals IR. So we do I times 100. Okay, so that's 12, which is equal to 100I. So I is equal to 12 divided by 100, which is equal to 0.12 amps.